So example 4 for 7.2. Some boaters use red aerial mini flares in an emergency. The path of one brand of flare when fired at an angle of 70 degrees to the horizontal is modeled by the function h of t equals -9 times t minus 3 squared plus 83. So don't let that confuse you. I rewrote it here. H of t can be replaced with a y, just means a function on t, which our functions are often represented with y, equals -9 times x minus 3 squared plus 83. So it says h of t is really the height in meters, and t is how they're representing time in seconds since the flare was fired. Still works the same with y and x. They've just chosen those letters and those variables to help refer them to what they're talking about. So h for height and t for time. So the first thing it says is sketch a graph of the function. So we know we can use a table of values. What I want to show you in this example is how to use that with our technology. So when you're on your graphing calculator, you choose your y equals, and some of your buttons might look a little bit different, but for the most part you guys should all have a y equals. So that's what you want to click first. We just want to type straight in -9 bracket x minus 3 squared plus 83. And you just hit graph in the right hand corner here. So as we can see, this isn't the best window for us to see this graph. I can't see my vertex. I can't tell where the top or the bottom is, if it's a max or a min. We know there's a max because it's opening down. It's a -9a value. But to do that, we just want to change our window. So this button here, we hit window. And right now it's identifying the lowest x value and the highest x value is -10 to 10, going up by a scale of 1. And our lowest y is also a -10 and our highest y is a 10, going up by 1. So we can change that to whatever we want so that we can see the best picture of our graph that we can. So this question's in terms of height and time. So for both, we know it's going to be whole numbers. I'm not going to have anything that's going to be less than 0 anyway, so no integers. So I can have my lowest x value be a 0. I can go down to my x max. We're talking about seconds, so let's say 20 seconds. Leave it going up by 1s. Our lowest y value we talked about, our height won't be less than 0, so let's keep 0 as our lowest. And our y max, let's say 100. Just as a guess, and we can change those once we graph it. So we'll hit graph again, which is a much better picture, but there's still a lot of empty screen. So let's go back and edit that. What that means in our graph is I don't need as much of an x-axis. So if this is 20, even if I narrow that down to 10, that'll be easier for us to read. So at x max, I'm only going to go up to 10 on my x-axis. Even better. Again, you can change it. You can keep going down, say even 8, but you don't have to. Whatever allows you to see your graph the best. Perfect. Okay, so we've sketched our graph. We've played with our windows. We know how to see that graph without using a table of values. Part B says, what is the maximum height of the flare? So in other words, what's our vertex? How high up? What's my highest y value that this graph goes up to? So to show you how your calculator solves for that, we want to hit second function and then calculate right here, which is actually going to be your trace button. So second function, which lets us choose those words above the button. We want calculate. We can solve for a certain value when x is a certain value, a 0, so our x-intercepts, a minimum value or a maximum right here, and this is what we want. We want 4, so go down to 4, enter. Our calculator says, are you left-bound? Are you on the left-hand side of that point? No, we're on the right. So let's go to the left-hand side somewhere of that max point. Let's say here. How about? Enter. Yes, I'm left. Now we want to go to the right side. Drag that over with that button. Yes, I'm on the left side. Are you ready to guess? Yes, I am. My calculator says the highest point is when my x is 2.9, sorry, so about 3 seconds. My graph reaches a height of 83 meters. So what's the maximum height of this flare? Well, we can answer that with 83 meters. We'll bring that back in. Part C. How many seconds until the flare hits the water? So that's going to be, we know it starts at a 0 second, 0 height. What's my x value or my x-intercept on this side of my graph when that height now returns to 0? So a few different ways we can do that is just by tracing, or we can solve for our zeros. So when we go second function calculate, we can solve for our zeros here. So we can go down to 2, Zeros are our x-intercepts. We need to be left bound, so really in this case it's going to be above the point as close as we can get, where our y value is still positive. So now I'm on the left-hand side of that point, I hit yes. Right bound, I just hit one more where I'm negative, yes. Please guess. My x value is 6.036 when my y value is 0. So my x-intercept is 6.04 seconds. I'm writing with my mouse right now, so it's a little bit tricky. Seconds, sorry, I almost wrote meters. 6.04 seconds is when my graph ended up being back down at a height of 0 when I hit the water. Part D, if the flare burns red for 2 seconds, how high is it when it burns out? So what's my height? What's my y value when my x is 2? So you can hit trace here, and this allows us to just move along the graph wherever we want, and it'll tell us our x and y value. So I can just scoot along, going backwards until I find when my x is 2, as close as I can get. 2.04, 1.95, so about 73 to 74.7. So I'd say 74 would be close to the middle there when it's actually at 2. That's more of a guesstimation. So what you can actually do is second function calculate for an actual value of your choice. So we hit value. When my x is 2, because we said 2 seconds, what is my y value? Solve. And the graph says it's 74 exactly at 2. So the height of my flare after 2 seconds when it burns out, it was at 74 meters. Perfect. So again, your calculators might not be identical to this one. This is a TI-83, a couple years older, but some of you do have this one. If you're struggling with it and not being able to graph or solve for your zeros, or you're using the trace button, just bring it to me. I'll be happy to help you with it. Your assignment is on page 369, number 1 to 7, 11, and 13. Let me know if you have questions. Good luck.